Hi everyone. Okay, you should have just watched the introduction video, which is generic for all three classes, but now I want to focus on the physical science class. So I hope you have your books in front of you, and you should have already read some, because although we didn't have class that first week, I did invite you to classroom, and I did give you reading assignments for Wednesday, Thursday, Friday of last week. So now we're on September 9th, and it's our first class. And so hopefully you've gotten used to your book. You went and took some time to do it, but this is your book. And I wanted to make sure that you know how to use this book. It's actually supposed to help you. And so there's certain sections in it that are helpful to you. And if you have, Mrs. Sagert was going to hand out little post-it notes that you could put in there to mark certain sections of the book that you're going to need to go to occasionally through the year. So this is your book. If this is not your book, you might be in the wrong class or you ordered the wrong book. So take care of that. Now, in the beginning of your book, there are some pages that just kind of give you one I want to show right before the table of contents. That's what this page is. I know you can't read it. There is some book extras. So I want you to look at that. It's on the left side, and it says book extras at the top. So it's page 8 in Roman numerals, V111. And there is a website that you can go to, and this is the password, Awestruck by Creation. And there are some good helps there. There's some helps with the labs. There is some information about each chapter. And go when you're at home, get on your computer, go to Apologia and find this, put in the password, and see what you have there at the beginning of the year. So then you know, oh, I'm stuck on this one. Where can I get some helps? Okay. So again, it's by the table of contents, which I know you can't read, but open up, and I would like you to put a tab there. Okay. It is Roman numeral 9, so IX, and put a tab there because this is the table of contents. And if you go through the table of contents, I'm just going to mention a few things. Let's just look at it for a minute. We're going to start with the basics. We need to learn the scientific method. Some of you probably already know it, so it'll be a review, kind of a nice way to start the year without any real heavy stuff that we have to learn. But very important stuff that we have to learn. So it talks about all of the basics, like how do we make observations? What am I observing? Well, you observe your senses. So what did it look like? And descriptive words. Don't just say it looks mushy. Say it's green with fuzzy area and it's, looks like it's decayed or whatever. And maybe, be a little creative what you use for observations, because we have to be able, if someone reads your data, reads your observations, they need to be able to make a mental picture of it. Because if you're like me, you can't draw it. You can't draw what you just saw, but maybe with words and some drawing gives them a better idea, because we want to communicate our data. Okay, so observations. What does it look like? What does it smell like? What does it feel like? Now, taste in science class, you do not do taste unless I or another adult tell you we're going to taste this experiment. So please don't make it a game. Don't taste it. Don't say, what if I did? No, that just wastes time. So just don't. Don't put it in your mouth unless that's part of the experiment, which we will make very, very clear. Safety is very important in science because you're going to be working with tools and different chemicals, and we don't want anybody getting hurt. Okay, so we're going to stay in our lane. We're going to keep our hands to ourselves. We're going to follow directions. So table of contents, basics, turn the page, module 2, chemistry. So we're going to review some things, and there'll be some new things about elements and atoms and metals versus non-metals, how to test the hardness of something, a bunch of those kinds of things, a physical change versus a chemical change. And then we're going to do more atomic structure. What is the atom? We'll learn some of the periodic table. We'll learn how it's organized. It'll be very fun. That's module 3. Module 4, chemical bonds. How do chemicals actually stick together? We'll learn how to do some balancing of equations. We'll do it's really fun. Chemistry is super fun because if you learn chemistry, that's how everything in our world stays together. So how did it bond? How do I break it apart? If I put this with this, is it going to be an explosion? Is it going to be toxic gas? Is it just going to make something pretty? We can do that with the periodic table. So I'm going to show you how we do that. It's so amazing. And then we're going to do reactions and the energy exchange during reactions. And then we get to the physics of motion, the physics of forces, the physics of energy. We do waves and sound. We do electricity and magnetism. And then we study the earth, like our earth, the atmosphere, the chemistry of life sciences, and then we're going to learn how to do some physical research. So we're going to work on conducting research, getting started, and how to build that into an experiment, maybe a long-term experiment, answering some question that you've had for a long time. And I'll teach you how you would set up the experiment so it's actually valid, and we can use the information to learn something about our world and maybe invent something new. Maybe we have some hidden little inventors in this class. I hope so. So that's in the beginning. Really cool. I would take some time and just look through it because you'll get to see what you're kind of going to do. Then there's the first module. And the first module is called the basics. And I would put a tab there. It's on page 1. So get your Post-it, put a tab on number 1, and that way for this one, I would move it each module so that you don't have to go through. But it's kind of cool. I don't know if you can tell on this book, but they have little dark sections. So you can find the different modules just by looking at, Mrs. Sagert will show you. You can kind of find them, but I recommend putting a Post-it there, and then you move it each module so you can quickly get to the beginning of the module when you come to class or when you're studying at home. Now I want you to flip way to the back. On page 525 is the glossary. Now the glossary is all of the words that are possibly new to you, that are specific to physical science, that you can look back to. Let's say, oh, you're reading along and you're like, oh, I forget what that word means. You can look it up back here. And what's really cool is at the end of the definition, it tells you what page it's on. So you can even go back and find out, oh, and refer to what it was around, the information around it. Okay. So you get a better context, an understanding of how to use that word. So put a Post-it back there on page 525. Really helpful. I don't want to get to April and people go, you mean those words have been in the back of the book all this time? Yes, they have been. So mark them. Mark them. Okay. And then one more tab, one more Post-it. On page 541 is the index. So sometimes the student next to you will say, oh, I don't remember, what did we use Alka-Seltzer for? So you look in the index and it goes, oh, Alka-Seltzer, page 7 and 8. Let's go look what we did. Oh, page 42, page 70. So please mark that, okay? Page 541. So hopefully you have 4 tabs or 4 Post-its in your book. Okay? Now, let's look at the first module. Go back to page 1. And I'm not going to spend a lot of time on it, but I want to point out some concepts that will help you with this module. So on page 1, they just talk about the fact that we're going to talk about the basics of science. And in this course, it says natural notes, so open to page 1. In this course, you're going to learn a lot about the non-living natural world around you and the universe it's in. You will study things that are familiar as the air around you and others as mysterious as gravity, radioactivity, and quarks. You will learn about the structure of the Earth as well as how weather affects the Earth. These topics and many others like them are all a part of what we call physical science. So, kind of tells you this is what we're in for this year. And if you turn to the next page, it's going to tell you what science is, and it's going to show you some of the technology and the timeline of how things were introduced to our world. When the telephone, when it started, look on page 3. It looked a little strange, okay? But it's gradually progressed, and now who knew we'd be carrying around this phone in our hand that was a better computer than they used to send people to the moon. And we're just carrying it around, right? So they also separate sciences into categories. We have the life sciences, study living things. Physical science, physics, chemistry, astronomy, okay? Geology, non-living things. And then, and earth science, that's where the geology comes in. Oceanography, it's not the living things in the ocean, it's the ocean. It's the water and the salinity, how salty it is, and the temperature and all of that. Meteorology, so weather, and paleontology, which is things that already died and we study to learn about them. All right. Now, if you should have something to take notes on, because I really want to spend a few minutes on the scientific method. It is on page, hold on, I'm hanging up my phone. Okay, so on page 5, we're going to talk about the scientific method. The scientific method is all about observations. So the first thing, the way science comes about, is people are out there and they see something and they go, I don't think I understand that. Maybe I should study it. Maybe I just watch it for a while. Maybe I just then, once I've watched it for a while, I start thinking about, what do you think makes that happen? Why did you think it changes and all that? And so science is driven by observations. So the first thing you're going to do is you're going to make observations. So you're going to write that down. This is on your page, you're going to write scientific method. Okay, scientific method. The first thing is you are going to make observations. And from those observations, we come up with questions. We're going to come up with questions that we want answered. Okay? Why is this plant closing up at night and opening in the morning? Why is this rock cracking? Why is the cloud forming? How do we get a thunderstorm? What about, like, if I put this substance with this substance, it gets warm, or it bubbles, or it smells really bad, or it smells really good. These are all questions. So first we make observations. We want to get really good at watching our world. Then we're going to ask questions. And those questions sometimes will come up with something that just sticks with you. Like, okay, I'm going to figure this out. So why is this happening? What is going on? So what I do is I make a hypothesis. A hypothesis is simply an educated guess. I've watched this for a while. I think this happens because this. If I do this, then this will happen. An if then statement. Okay? So make observation, come up with some questions, then pick a question, pick one question at a time, and then make a hypothesis. What do you think would happen? Now, once you do that, if you want to actually test that hypothesis, you're going to have to design an experiment. Okay? So, number 4 would be design an experiment. So, if you've never done that before, one of my hopes is that by the end of the year, you'll be really good at coming up with experiments. So I'm going to try and do experiments with you every week, and we'll go over the scientific method, because how do we learn? We repeat. We do it again and again, and we make mistakes and we correct and we learn. You learn more from mistakes than right. So don't be afraid to make mistakes. All right. So we've developed an experiment, right, to test our hypothesis. So first we make observations, then we come up with questions, we pick one, make a hypothesis, and then design an experiment to test that hypothesis. All right, once you do that, you run the experiment. So you actually experiment. Hopefully I'm not going too fast. Hopefully you're writing this down. It should be part of your notes. So make observations, come up with questions, make a hypothesis on one of your questions, design an experiment, and then run the experiment. Now, 2 things happen when you run an experiment. Your hypothesis is correct, your hypothesis is incorrect. All right. So I'm just going to put correct, incorrect. All right, so if it's correct, which, honestly, most of them are not. The ones you're going to do have been tested a lot, so your success rate is going to be pretty high. But if you do this all on your own, most people, the first time they do an experiment, the hypothesis is incorrect. But let's say it's correct. So what do? If it is correct, then you write your conclusion. You talk about what you analyze the data, you look at it and go, it was correct because of this. This shows me that it was correct. Maybe it's numbers, maybe it's an observation of one of your senses. Sometimes it's a measurement. So it might be, inches or centimeters, and maybe the temperature changed and that was your hypothesis. The temperature will go up, it will increase. And you went from 2 degrees C to 15 degrees C. You analyze and report. Okay? Now let's say it was incorrect. Bummer, but not really. If it was incorrect, we could just say it's incorrect, it didn't work, this is what happened instead. But generally what we'll do, if it's incorrect, is we will go back and we will make a new hypothesis. And then we'll change up the experiment to reflect this hypothesis. So write that down. If it's incorrect, you're going to go back up here, change your hypothesis. Don't change your question. Okay, that invalidates everything. You're still doing the same question, but you weren't right with your hypothesis. So now we're like, okay, we were incorrect. I'm going to make a new hypothesis, a new educated guess of what's going to happen using the information you learned down here. Design a new experiment. Well, you're basically designing, changing the experiment to be more specific. Okay? And you pretty much will do that until you get something correct, or you just get tired and bored with the whole thing and you stop. But we generally just test and retest until we get we get a conclusion that then verifies our hypothesis. So I think this page is pretty important. So you should have it in your notes. And when you're studying, you should go back and you should look at this again and maybe cover it up and have a sibling or a classmate. Can you tell me the scientific method without me seeing it written down? Like, I want it in my head so that when I'm in class doing experiments, I'm like, okay, I got to make some observations. Okay. So when you study anything that's a chart or a graph, you're going to want to look at that every day as you study. It's part of that hour of review. So you read new things and then you review the past stuff so that by the time you get to the assessment, the test, you've encountered this stuff 5, 6, 7 times and it's in your brain. And then you don't freak out about tests. Okay. So hopefully you have the scientific method. This is used all around the world, even to this day. So good stuff. All right. Then we come to the first experiment. So you should have a sheet that you're going to follow because I will have it copied and ready for you. And Mrs. Sagert has the supplies. Look on page 7. Because I know I'm not there and I'm missing out on all the fun, but Mrs. Sagert will have fun with this. And it's an experiment that's a little different because it's just about making observations. So you're going to do a real simple make observations. You know, we learn things step by step. When you were a baby, you didn't get up and run across the room. You got up and you waddled and held on to things, and then you walked, and then you fell, and then you eventually ran. Okay? So baby steps. And it's very important that you do these baby steps because it's easier for us to correct you in one step at a time rather than, oh, we did the whole experiment and it's all a mess and now you're defeated and we're not going to do that. So you're going to explore quantitative versus qualitative. So quantitative, what do you think that means? Sounds like another word like quantity, the quantity of something, maybe how long it is, how much it weighs, how much space it takes up. Quantitative. Okay? Qualitative is a little different, right? So we're going to do an experiment. I'm explaining it right now, and then Mrs. Sagert's going to explain it, and you're going to do it. But we're basically going to take Alka-Seltzer, an Alka-Seltzer tablet, a small solid object such as a pebble or an eraser. You'll have a little eraser that's kind of about the same size as the other, a magnifying glass, a centimeter ruler, you're going to have a balance scale, you're going to have a beaker of water, and you're going to have a stirring rod or a spoon. Okay, so it has all the materials. Then you're going to go through the procedure. And the procedure is examine a small solid object using your senses in the data table in your student notebook. So wherever you're keeping notes, make a list of your observations, and it cautions you, don't taste it, don't put the Alka-Seltzer in your mouth. Observe the object with a magnifying glass and record what you see. Don't say, I see an Alka-Seltzer tablet. No. What does the Alka-Seltzer tablet look like? What color is it? Does it have any writing on it? Is it multi-layer? Is it a square? Is it a triangle? Is it a circle? Describe your senses. Okay, does it smell? I don't know. Okay, use the kitchen balance to determine the weight of the object. All right, so you'll have your balance scale and you'll weigh these things and record the weight. Okay. Place the object in a beaker of water and stir. Record any observations. What happened? Just sit there? Did it make bubbles? Did it give off a different odor? Did it change color? I don't know. You will know. You're going to write it down. Okay, remove the object from the beaker. Repeat steps 1 through 5 for the Alka-Seltzer tablet. So you took your eraser or other thing and did that, and now you're going to repeat it for the Alka-Seltzer tablet. Record all observations in the data table. So you're going to end up with observations about this eraser or small object pebble, and you're going to have observations about the Alka-Seltzer tablet. Empty the beaker down the drain, rinse the beaker, and return it. Return everything. Important to clean up after you. I'm not going to come after you. Mrs. Sager's not going to come after you. You're going to be in groups, and you guys in groups will clean up your mess, return everything. There's usually a cart, rolling cart, where we keep them. So you're going to wash what you need to, and you're going to dry it, and you're going to take care of it. And then it leads you to a conclusion. Answer the following questions in a paragraph, so complete sentences, as you sum up what you learned. How did the appearance of each object differ under the magnifying glass? So now we're comparing the eraser or pebble to the Alka-Seltzer, right? How did they change when you saw them with your eyes and when you saw them with the magnifying glass? Which data were obtained by qualitative observations? And I'm not going to tell you, but quality, what does that make you think about? The qualities of something versus quantity, like actual measurement stuff, where you get a number. Over here, qualitative can be kind of mushy because it's blue. No, it's greenish blue. No, it's aqua. No, it's purple, whatever. But what you observe, don't put what your neighbor put unless you agree. But it's what you observed with your senses. Okay? Which data were obtained by quantitative observations? So you're going to list which ones told me quality of the object, what I observed with my senses, and which was quantity, where I actually measured it. Gram scale, mass scale, and centimeter ruler, right? Quantity, numbers, and qualitative. It stunk. It was purple. It bubbled, right? Quality, the qualities of a person, the quantity of a person. So when I go to the doctor, I get weighed and measured, right? Quantitative. But they also, oh, your skin looks kind of pale, or, ooh, you have a rash, or, wow, you look great, right? Qualitative, okay? How did the instruments extend the observations you made with your senses? So write that down. You can come up with that. Think it through. You can do this. How did the objects change when placed in the beaker of water? So how were they in the beginning? Compare them. And then at the end, what happened? Okay. Now that does not sound like a hard experiment, and you would think you could just do it really quick, be done, move on. Please take your time, work in a group, help each other make observations, make measurements, be accurate in your measurements. Okay. So you're going to be doing that in class. And then we get to just reviewing the scientific method by reading. And they're going to talk about controlled experiments and variables. Read it. You don't have to be perfect at it the first module. We're going to talk about it. but you need to read these things. Okay. So it will take you through several pages. And then the following week, we will come in and do another experiment. And I'll explain that on another video for you. But I want to point out something at the end of the module. So page 38, turn to page 38. It is the study guide. And at the end of every chapter is the study guide. And you have to define all the terms that are in the front, in the back, and you have to answer all the questions in complete sentences, unless it's just a number. Like if they have you measure something, you can just say 12 centimeters, okay? Doesn't hurt to do a complete sentence, but it won't affect you. Sometimes it's just a blank. Now, all of these things are due at the end of the chapter, either the Wednesday or Thursday before the test. The test for this module will be September 23rd. So you have a couple of weeks from the 9th to the 23rd to study all of this. Another thing I want to point out, find where the on your owns are. They're right before, they're on page 36. And you'll see those as you're going through because you'll read a section and then there'll be a little part that is in green and you'll stop at that and you'll answer them, put them on one document in Google Classroom, then it'll save it, and then come back the next day and do the next ones, put it all in one document, okay? All right. So I am going to, I think, stop for this one because the first day you're going to go over all the information about science and then you're going to do this experiment. So I think that'll be enough for this one. So I'm going to stop. I hope you have fun with the experiment and use good techniques. Okay, be careful about the equipment, use safety, nothing in your mouth, and I will see you later.